Good morning. Welcome back to the lecture series. In this lecture, we'll be discussing about the microstrip patch antenna using coupling techniques for wireless communications. So here we'll see what are the different types of coupling techniques are available currently performance of antenna. So this when we enhance the performance, which it can be useful for the communication purpose like wireless communication. So let's get into it. So why we need it, like today we antenna requires like a cheap and compact. So whenever we where we make it too much of compact thing, then we can work for the we can fit into the any devices for like IoT devices and etc. Whereas that but it has to work in the complex environment. So wireless communication supports the large amount of data traffics in order to handle the increased wireless device communications. So always we focus on the compact, high gain, large bandwidth and high efficiency are playing the major roles for the wireless communications. Why, what motivate us to go for this coupling technique is like when we have the signal attenuations due to the increased number of the wireless connections, and then the dispersion of electromagnetic energy during the transmission and limited bandwidth and low gain values. To meet these challenges, the novel structures are designed and investigated. Therefore, the aim of this work is to focus on the to improve the performance of microstrip patch antenna and explore the usage in engineering environment. So before getting into this, I'll explain about the what are the different types of coupling techniques are available. So here, coupling technique is like to make an efficient communications. We use a different coupling techniques like we use the air gap or else the shorting pins and feeding network, like providing the external feeding networks. And we use the different type of structures where we create a structures in the ground plane of microstrip patch antenna, or else like we used to keep like on the top of the patch antenna like parasitic elements. Then the parasitic patches are we are placing around the top of the patch antenna, and then we go for the impedance surfaces where we disturb the ground plane, or else like we place the one more layer of it, and we use the next one is the partially reflecting surface. This partially reflecting surface is placed as an separate layer, like super substrate layer, and which it can be for getting the beam to be the directional beam with a narrow bandwidth. We go for this, and we use in this application like radome. We use the most of them will be in the in the PRS, partial reflecting surface are used. So here I'll be discussing about the few techniques like defected ground structure. Like defected ground structure is like creating a simple or the multiple defect in the ground plane to disturb the current distribution. For example, here I have shown you the different types of defected ground structures like dumbbell shape, and this is the spiral shape. And here is a two dumbbell shape, and here arrow shape, so spiral shape, meander shape, and here we can see as in a concentric ring shape, a split ring, we say this, and this is a meander line, circular dumbbell, and here it is of a U slot, and here we have the two U slot with the connected open dumbbell, we say as, and this is like a fractal type, and this half circle of U, half circle of V. So there are many different type of the structures which we create a single or the multiple defects in the ground plane. So let's next is like we'll go for the metamaterial structures. So metamaterial is an artificially medium which it exhibits a unique characteristics such as the negative permittivity, permeability, and the refractive index. So why we use like we metamaterial is like we are going to modify the structure as per our requirement. Either if we need what type of the classification it gets false. For example, metamaterial is classified into four different classes like based on the permittivity and permeability. For example, if we have this permittivity is greater than 0 and permittivity is greater than 0, we called as an forward propagation. And if it is both our permittivity and permeability is less than 0, we called as an backward communication propagation. So whereas like next is like when the permittivity is less than 0 and permeability is greater than 0, we called as an no transfer, that is of plasma thing. And one more is a negative material where we call as a magnetic metamaterial, which is of permeability will be less than 0 and permittivity will be the greater than 0. So this is like based on our requirement we use it. And here I have shown the different types of metamaterial available, like of 2D structure, which is printed on the both substrates, and 3D structures where we connected with the wires. And 2.5D we call as 2.5 because it's like we use the wires to connect between these 2D structures, but it will look like a 2D printed with 3D, right? So here we have a 3D structure. The 3D structure is like we have some gap between this top of the substrate with an material printed structure. So this air gap with an substrate we called as an 3D structure. So mostly we have focused on 3D structures. So next is like reactive impedance surface. So reactive impedance surface is an array of periodic structures where it build a dielectric substrate. And this reactive impedance surface is like called as an artificially structure where we can able to improve the performance of the patch antenna. It improves the antenna performance like miniaturization, wideband responses. Next is the partially reflecting surface. The partially reflecting surface is a metallic dielectric periodic structure located approximately half of the wavelength above the radiator. So this set structure is a compact structure which is ease of high directivity. Already I have discussed here. So far we have seen about all the structures. So next lecture we'll be seeing about how the DGS and each thing layer has been designed. So thanks for watching.